Welcome to clickmyproject.com. My project title is Reliability Evaluation of Large-Scale Battery Energy Storage Systems. Let us see about abstract of our product. Electrical power is the most widely used source of energy for our household equipments, industries, and workplaces. Population and industrial growth have led to significant increases in power consumption over the past decades. Increase in demand for power and depletion of conventional energy sources have made it necessary to move towards the renewable energy sources for power generation. Traditionally, frequency regulation in power system is achieved by balancing generation and demand through load. Following examples such as spinning reserve and non-spinning reserves. In such cases, energy storage and responsive loads show great promise for balancing generation and demand. In this proposed work is concerned about the reliability of large-scale energy management system. The battery conditions are evaluated by a weighted ampere hour throughput method, and also it have a DC to AC power electronics converter module. This proposed work including comparison of classic battery energy management system. The simulation results verify that the design controllers can improve the control performance significantly. The comparison results show that the proposed reconfigurable battery energy storage system has higher system reliability and more power output than the classic battery energy storage system. Next we see about flow diagram of our product. Before that we must know about what is energy storage system. Energy storage system can bring about a reduction in operating cost that can increase their usability of photovoltaic and wind generator electricity by making this generation coincident with peak load demand, and it may facilitate the inclusion of wind and solar energy into the electrical grid, and it can increase the existing transmission and distribution equipment and eliminate the need for expensive TNT additions, that means transmission and distribution additional equipments, and it also can be used to reduce the load on peaking transmission lines. Conventionally, in this design, all the battery modules are connected in series to form a string. It should be noted that there can be more strings connected in parallel for a battery energy storage system. All the battery modules share a DC to AC converter and that are connected to the power grid through a 3-phase transformer. The DC to AC converter may consist of several power electronics converters that are connected in parallel to reduce the size of each converter, and that conventional method having several disadvantages, such as it decreases the series connection of number of components that affected the overall efficiency, and the component reliability is decreases, and the system in which the components don't have a very high individual reliability. Those disadvantages are overcome by this proposed system. A reconfigurable battery energy storage system is designed in a way such that the failure of individual battery modules will not cause the whole battery energy storage system to shut down. It consists of energy storage blocks, that mean battery modules, and DC to AC electronic power converter modules, and a multiple winding power transformer. The multi-winding transformer is used to integrate all the battery modules, which also enables the independent operation of each battery module. Each battery block in the reconfigurable battery energy storage system is controlled by its individual converter modules, and to quantify the C rate related failure rates of power electronic converter components, and the power losses of a power electronic converter are mainly the power losses in the IGBT and diodes. This is the flow diagram of our product. This diagram consists 3 battery modules. That means each battery modules are connected in parallel. The output of the battery source is fed into the 6-bridge inverter. Each inverter having 6 thyristors or IGBT or MOSFETs. Here we using IGBT, and each inverters are connected in parallel with their DC source. Then output of the inverter is fed into the multi-winding transformer. Multi-winding transformer is nothing but the 3-base transformer are separately connected in a manner, and the output of the multi-winding transformer is fed to the power grid. Next we see about running process of our product. In our product having 3 battery modules, and 3 battery modules is connected to a 3 6-bridge inverter. In 3 6-bridge inverter having 8 IGBT switches. Each IGBT switches is triggered from the pulse generation circuit. Here we using space vector pulse width modulation technique. After the output of the 3 6-bridge inverter is fed into the multi-winding transformer, and the output of the multi-winding transformer is fed into the power grid. The load are connected to the power grid, and after the connection of all modules is run in the run simulation icon. If each output is displayed in the corresponding window. The first one is input battery source voltages. Totally 3 battery modules are connected, and each battery module's output voltages are separated. And the next one, the space vector voltages. This is the pulse generation circuit output. This is the space vector voltages, and corresponding output pulses are shown in here. And next one is the output 3 base voltages. Next, the output base voltages separately VAN, that means the voltages is taken between the A base and neutral. This voltage level is shown here. Next one is the output voltage of base voltages for each bases VAN, VBN and VCN. Next one is the line voltages. That line voltages is getting from line A and line B. After the line B and line C and line C and line A respectively. Next one, the 2 base voltages and corresponding 3 base current. The 3 base current is getting from the filter circuits, so the harmonics are reduced here, and this is the output harmonic waveform. Here the output harmonic value is shown. That value is 26.27. So this value is compared to conventional method is low, and this overall reliability is increases compared to the conventional battery energy storage system.